welcome back everyone, and welcome to the Control Loop. I am your usual host, co-founder of EternaX, Daria. Alongside me today is Pars, also co-founder of EternaX, and today's episode's special guest, our Chief Scientific Advisor and Principal Research Chair on Blockchain of University of British Columbia, Dr. Chen Feng. The topic we're going to be talking about is one of the most exciting and pivotal in this whole AI Web3 frontier sort of thing. It's multi-agent coordination, why agents need to coordinate, why they need to talk to each other, and how to implement it in the safe and efficient way.
Dr. Chen, to frame, today's discussion, what exactly is a multi-agent system and why the coordination is such hard, for us to achieve?
Yeah, so you can think of a multi-agent system as a network of intelligent agents that work together. Sometimes, like they compete to improve the performance, and the goal is as a team, and they should be able to solve complicated tasks. So these systems can be anything from robot swarms to AI assistants, but pipelined together for some interesting tasks, or some like automated bots on a blockchain. Right? This gives you an idea of how they will look like. Now, the tricky part is getting them to coordinate smoothly and securely. So this is what is sometimes called workflow optimization in Web 2, but in Web 3 we have one more requirement, which is the security or public verification. Right? So this makes the design and the implementation even harder. So, and another perspective, without shared memory, trusted signals, or aligned incentives, like agents can quickly become uncoordinated, right? That's why we need like Web3 lab to enhance this, to align them, to provide shared memory, to have trusted signals. But with all this in mind, you will see that solving coordination at scale indeed remains the biggest challenge towards this new and exciting research direction.
Yeah, this is absolutely correct, Dr. Chen. And in the economy of $22 trillion of the agent, basically the service industry and the software industry that is going to become agentic tomorrow, this trust layer will become highly critical over the period. Daria, my next question would be to you is from a protocol architecture lens, what's blocking the scalable multi-chain coordination today?
There is no protocol for scalable multi-chain coordination today. That's what's blocking it is that it doesn't exist. So all of the agents that are just like operating right now in various chains and various like Web2, Web3 environments, they're all operating like solo or maybe like in groups of a few that are hosted by the same company or the same group of people. They may have like, they're like a swarm that they have deployed. But worldwide, there's going to be more than 1 million of agents on all the various autonomous programs running around the world on various people's systems. But it's kind of like the early days, you can say, of the web. Everybody has their own kind of agent and page, but there is no way for you to like identify or discover them or know who they are, know what they do, and know how to interact with them, or whether it's even possible to interact with them. And the real power of it unlocks where you get the discoverability. So discoverability of like the internet and the social networks is what makes them so powerful and what allows network effects. But that's not something that we have with agents yet. And there is so many core things that are lacking that our different projects have tried to address different parts of it. And one of them is again identity, discoverability, persistent memory, so that your agent doesn't lose what it is or what it was doing before, reputation of all these different agents. How can you allow them to do services, anything that for them to actually do any chain, transact, and manage whatever resources or compute they have. They have no trust, no context, and no collaboration rails. And until all of the above becomes like programmable, we'll not really have like real world agent collectives or any sort of collaboration.
Yeah, this is completely true, Daria, and these are the core pillars that we are addressing at our end for this aging economy. Daria, you mentioned about identity, and Dr. Chen, I would love to understand your perspective here. Is why this critical verifiable identity is required, and what is beyond signatures, what we have already been seeing in the cryptography space. So what can be beyond this in the space?
Sure, yeah, that's a very good question. So first of all, identity is essential for making agents accountable. As we discussed before, right, this accountability is very important when it comes to larger scale, like this agent teams or collections. And beyond the basic signatures, we are working on different ways like to verify agents' behavior using cryptographic proofs such as TEs and zero knowledge proofs. And with even more, right? And we are like trying to assign reputation scores based on the past tasks of agents. So combining everything here, you can think of this like identity component as a KYC check for agents, but like it is verifiable on chain. This is very important. So these tools can prevent spoofings and make it very possible for agents to trust each other. But finally, I just give you maybe a related example to show the importance from another perspective. I think many years ago, maybe 5 years ago, at Blockchain UBC, we were building this identity layer for some healthcare applications because there, right, privacy is important, and also our like identity system should be compatible with all these like regulations. So right, and the kind of the previous work there put me in a much better position and in like creating this identity for AI agents.
No, thanks for this download, Dr. Chen, and I completely agree with you on the point that beyond just being an identity, we have to provide kind of a KYC structure for the agent and reputation graphs, and that is the main focus. Like we have to see agents as individuals of today. So agents would be as individuals are today, and we go on LinkedIn, we see different professionals, we see some repository of their work, there is some trust system out there, and on that basis certain transactions are made and certain decisions are made, and that is the kind of trust we want to develop for the agents of the future. So completely agree with you. And Daria, on this point, my question to you would be what are we doing at EternaX for these primitives at the protocol level?
I mean, we're certainly building on the strengths of everything that has been built in decentralized systems and specifically in blockchains so far. And we're very lucky that blockchains and like just decentralized consensus and peer-to-peer networks already provide a very good foundation that solves like a bunch of those problems that we have just described. And specifically at EternaX, we have designed a protocol that is based on those decentralized systems, but is enhanced with the idea that the first class citizen of a decentralized system is going to be an AI agent. It is not going to be a person. It is going to be a digital entity. It is going to be a program. So to allow that, we are embedding like this message passing protocols that allow you to have interface for agents to coordinate on each other, for interface for agents to know what other agents are on the chain, to have a unified way of calling each other and having a unified way of verifying the performance of each other, and then the reputation of also all of the provided infrastructure that needs for those agents to run, because you need the data providers, you need the oracles for the real-time data, you need providers of actually LLM, and all of those are going to have reputation that are going to be checkable by agents as well. So these aren't just like wrappers on LLMs. It's like a full-fledged system where everything is native on the protocol level. It allows agents to be like first-class citizens. They can own, they can transact, they can trust each other, they can maybe even punish each other if they're not trusted, and like leave.
No, very true, Daria. And by design, I think at EternaX, what we are enabling for different providers who are node providers from maybe from the memory side of things or context sharing or from the side of compute, they all have an opportunity to join in the revenue sharing, and they can contribute as passive individuals and still get a share of the economy. So I think that this is good. And one thing that has, brought in all this is that multi-agent, when we are saying multi-agent systems, multi-agent systems basically mean that there have to be agent swarms. And this raises a question for us is like, why do we even need agent swarms? What is the need for agent swarms in the industry today? What are the use cases that they can be used for? So if you can help us understand, Dr. Chen, what are the use cases that you can see for these agent swarms?
Mhm, mhm. Yeah. So maybe we can think in this way. When agents coordinate in large groups, that is what we call swarms. They can unlock big opportunities. Maybe two quick examples. What in finance, if we have hundreds of bots, like they can coordinate trades or the so-called arbitrage strategies. What they can kind of think about this from different perspectives, because in the current technology, each agent or each bot has like a limited memory, right? Has certain limitations. The reasoning time cannot be long enough, and that's why instead of letting one agent to do like hundreds of hours of work, currently impossible, we can let a large group of agents, right? Each of them and has some like specialization and doing things. And this type of collaboration is not only possible, but also kind of about near future. It's also related to how our brain, right, like different components, different parts work together. As another example, and in healthcare, different agents can negotiate insurance claims, but at the same time protecting all users' privacy, right? And this can be done and with kind of our like current framework, right, and our some like primitives. Okay, so and to sum up, with millions of agents expected in the coming years, and also right with this AI inference, AI usage exploding, the economic potential of these like coordinated swarms is indeed enormous.
No, this, yeah, I think, Shen, you covered it perfectly. And one example that I can give from my personal experience is, so there are various wealth funds, and there are millions of, possibly across globe there are millions of them. And the idea is that they all have access to the same capital pool, which is say across 5,000 stocks, but we still have them so many, is because there is different set of trust, and there is different set of issues that they are addressing. There's different kind of risk profile that they are addressing. So why not with the case with the agent of tomorrow? When they are addressing different risk appetite, they are addressing different markets, different geographies and stuff like that. So I mean, this is really good, and that's something that we can achieve from the swarms of agents which is across. So I think it is difficult for one single agent to actually do those things. um, why this brings me to the next very critical question, and that is this is what Daria, being the protocol architect. Daria, as humans, we have found it very hard. Economic alignment, which is, we don't know, what position somebody has to be given, what value somebody is giving, what amount needs to be paid, and stuff like that. So how do you design coordination? How do you design economic alignment around this agent coordination, basically?
Yeah, I think in this particular question, it's better to think about agents not like persons, but more kind of like companies or like businesses. Because each agent now, because it has its own access to its own capital and its own resources, and it can manage them, other agents can see their success or failure, and they can decide to stake with them so they can chip in into their success. Like when you buy stock of a company, you chip in with a little bit of your money and you gain back from their success or also going down. So this creates this sort of game theoretic environments where smaller agents back up better agents, some that maybe have access to some different, some private data that allows them to make better decisions or some other things. And this creates a wheel of like reputation increasing, then influences the matches that you do with other agents that are interested into taking the same decisions that you do, but not just by copy trading, but by actually chipping in and staking with your wallet and getting a piece of your success or failure. That's how like they are going to align into kind of like certain groups based on preferences and based on things that they do, kind of as like we see with funds. Most of the funds are not just one person. You've got more LPs and more people chipping in into where they feel more aligned. And so that's why you have bigger ones, you have smaller ones, but you have a lot of different ones. So we've seen that this sort of coordination allows you to get the best out of like distribution of economic resources out of agents, and it improves the success of DeFi tasks as well. If you have this sort of this collaboration where bigger agents take better decisions and others back them instead of everybody's trying to like reroute on everything at the same time, which is like very interesting. Is going to be actually to see it in the live network coming soon.
Yeah, definitely. I think this is something which works pretty well in the normal world as well. And we have seen, and you have rightly mentioned that the funds which are big enough, or who have basically garnered that kind of reputation over the time with real usage, the capital gravitates to them. More the capital gravitates, the more the reputation graph increases, and vice versa. And this is the flywheel that kind of makes them stronger
Yeah,
over the period.
exactly.
And
Yeah.
yeah. So Dr. Chen, with all this, we have come down to our last question, which is like, what's next? What's next in the space for agents research? What are we expecting? What do we want to see here? And how do you want to think about it?
Mhm. Sure. Yeah, so there are several very interesting research directions. Currently, we are exploring swarm cognition, which is about how agents can collectively think. Also, right, they can verification. Basically, they can prove that machine learning models do what they are supposed to do. But one more example is fair reward distribution in decentralized systems, because we want to ensure fair compensation. And maybe last example is we call it adaptive consensus mechanisms. Basically, like agents will help the consensus algorithms to be like better, like a higher performance, more secure, and so on. And we are kind of in the final stage, and we are going to submit some papers very soon on this topic. So to sum up, we believe that these protocol level breakthroughs, right, if we are lucky and to achieve all of them in the near term, they could open up new opportunities for multi-agent systems to unlock, right, this like $1 trillion agent economy opportunities.
Yeah, I think we're established consensus on this call that for everybody, like researchers, engineers, and buildings, that you can tune in into coordination, and the coordination is going to be the real unlock for agents and intelligence, and that's what got allow it to scale. So very, very exciting and actually be working on it.
True,
Yeah, totally.
true,
Uh,
Daria, and that thanks a lot for arranging these, this podcast, and we really thank Dr. Chen for, participating in this, and we'll be bringing more to you, to our listeners over the period. So just stay tuned to our podcast. You can subscribe us on YouTube so that you know when we can publish the new ones. And follow us on LinkedIn as well for the latest updates from us. Thank you, guys.
Thank you. Talk to you
thank
soon.
you.